This is the Matek Systems F765 flight controller board. I'm going to start looking at the ports and how to connect things to it. We saw me connecting servos to servo outputs 1 through 10. And on the F743 board, H743 board, there are also 2 more PWM RC ports out here, 11 and 12, that I tested on that one. But now we're going to start looking at these ports down through here in this area, which are the major ports for connecting things to. And the first thing would be a RC receiver connected to it, because after all, if you flew this in manual mode, you could connect an RC receiver to it and a couple of servos and motors and go flying a quad, an airplane, or whatever, and you'd never know the difference. You'd also never have any benefits of using the flight controller. You might as well hook the servos straight to the receiver pins and fly like you were 50 years ago. But we don't want to do that. So the first thing I'm going to do is we're going to look at the layout of the board, especially right in this area right here on the bottom right. So if we go up on the internet to mateksys.com and go to their products, flight controllers, and we go down and we look at the F765-Wing. Come on. Thank you. And we go and we look at the layout of the board. Here's where a lot of our information is buried. You don't get anything with the hardware. Flight controller comes in a bag, some pins, you saw me unbag it, some pin headers to solder on. That's it. You can find this data sheet on this site. And for right now, I'm not going to go through every one of these. We're going to do that as we go through each individual thing we want to connect. And buried right down here in the right, where it's not written anywhere else, you can see right here where it talks about RX6, UART6, RX for serial, RX by default. Okay, that's a fancy way of saying plug your RC receiver in here. Also shows here that PPM signals share RX6 pad. TX6, UART TX6 with soft serial enabled, TX6 soft serial with CPU based serial port enabled. So boiling this down, basically if you look right here, here's TX6 and RX6, and it's telling us RX6 is used for serial RX, basically the serial receiver. So on this pin we can put in PPM share RX6 pad right here, RX6. There are ways that you can also connect here with S-Bus. PPM, S-Bus, or you can connect to it as a UART, like it's talking here. UART6 transmit, UART6 receive, soft serial transmit, for serial receive by default. So that's using both these pins as a UART port for UART6. So right here immediately we have ground and 4 to 5 volts. So we can actually pick up ground and 5 volts right here for our RC receiver. And we can use these 2 pins to connect the RC receiver. And something else that's really sweet that we'll talk about in the future is there's another serial port right here, this transmit and receive pins for serial port number 4. This is number 6. This is number 4. This is number 2. This is number 7. This is number 1. This is number 3. This is number 8. The 765 shows a receive pin for UART number 5. But let me see here. There was some place. Okay, right over here. If you look, it says RX5. The RX5 pin, receive UART 5. UART 5 receive. No, well, maybe it is implemented. No TX5 on this flight controller. So there's a receive for 5 perhaps, but no transmit for UART 5. The rest of them are here. 1, 2, 3, 4, 5 again over here, partially implemented. 6, 7, and 8 UARTs on this board. Because UART 6 is set to serial RX by default, that's in the firmware on this board. So this UART 6 right here is just perfectly set up for an RC receiver. Now let me switch to the RC receiver that I've chosen, and we'll look at some of the reason I say that. And what I have chosen is this Crossfire Nano receiver. This one's got a little dipole antenna on it, but it's very small, very hard to see, I bet. It comes with 4-pin header that you can solder on, which I did to all of mine. My first time working with these. So I'm going to make it as easy on myself as I can. There's a little bitty button right there for binding. And then basically, without getting down into the receiver at this point, this pin is ground. This pin is 5 volts. This pin is servo port number 1. This pin is servo port number 2. So that's very convenient, especially if I were going to use this on the 765-Wing, let's go back to our chart again, our breakout. Right there, see, I've got those 4 pins right here, or 3 pins that I need. I've got ground, 5 volts, and I've got a receive signal. So if I, on this 3rd pin down, put an output signal on this that's a PPM pulse or a S-bus pulse, or even step or so above that, that's actually going to be using a UART type pulse. Right there's my setup. So I could run just your standard 3-wire jumper connector over from these 3 pins to these 3 pins in the bottom right of this, set this up for PPM or S-bus output, and I'm done. I don't have to do anything else. That's not what I'm going to do on my build. And if we look at the RC receiver I'm using inside my builds. You'll see why. So now if we go over to the TBS site where the Crossfire Nano receiver is, here it is. Ooh, darn, out of stock. Little $24.95 receiver. They're so sweet. I've just started using them. Here it is. This is what I was talking about. There's your little bind button antenna. This is the ground, 5 volts, servo 1, servo 2, servo 3, servo 4, 5, and 6, sorta, not really. And if we look down here, we can see that here is exactly what I'm saying. Ground, 5 volts power, channel 1 out, channel 2 out, channel 3, channel 4, VST, SCL, and SDA on these two. Not much else to say about this little receiver. That's the whole data sheet on it in the Crossfire manual. But truthfully, this receiver can be put in. Let's see if it does say anything in here about CRSF. Nope. There is a Crossfire protocol that's basically communicates on a serial bus. It does a whole lot of things for us. So, physical connecting wires. Right here, I have a 4-pin DuPont connector on the first conductor of the Crossfire Nano receiver. Right here, black wire. I have set up for ground, and you can see on the other side in the connector's first wire I have ground right here. Next wire over is 5 volts. You can see the next wire over I have as 5 volts to supply 5 volts to the RC receiver and ground so far. The next one over I have as a yellow pin. That's 1, output 1. I have that right here, yellow pin. Next one over in my little pigtail here is actually the blue one, and you can see the blue one is set up to go on number 4. Now then, there's 2 more you can see in there. The green one and the white one, and you can see they actually do run over here, and I'm going to use them out of this RC receiver for that next UART port that's sitting right next to the receiver that I was talking about. I'll show you how that works here in a minute. I ran into a little problem. You can see here I was set up to put some more pin headers down this line of ports on the RC receiver and plug this in to get 2 more pin outs of this receiver. It turns out these holes aren't even big enough to put pin headers in, so I was kind of flummoxed there and having to back up and punt again here. But I did have all of that set up in this side. So if we look back real quickly, layout of the flight controller, you can see that corresponds to my ground, my 5 volts, it's going to be CRSF receive. My transmit's going to be going to this receive. My receive's going to be going to this transmit pin. And then I'm setting up in the future to use this other serial port, UART4, right here, receive and transmit, right down the line. So if we switch back to our connector, this connector is going to go on this flight controller board right down here on the bottom right corner. Oops. The bottom right corner. There we go. So I just plugged in 6 wires, technically. And you can see them again. Ground, voltage, my basically two serial to serial port 6, two serial to serial port 4 to be utilized in the future. For right now, you can just assume that it's just these 4 wires. Now, I'm going to leave that connected there and on the table. And now we'll go back to the configuration of our RC receiver. And this time we're going to go into, on the screen, we're going to go into the TBS Agent X. I'm also going to put a USB cable in the flight controller. That's going to fire up our RC receiver, because I have a Crossfire transmitter sitting right here, also connected to my computer USB. And what we've got going on now is we can go in here, and this little Crossfire Nano receiver, I can configure it by clicking right here. I'm not going to get into all its setups. We can do that in a different video. But right here, I went in here and chose from a list whether I wanted channel 1 to be channel 1 through 12, whether I want it to be an RSSI signal, an LQ signal, or a combination of RSIs, I and LQ. I want it to be a PPM output. I want it to be an S-bus output. NI S-bus. I think that's a non-inverted S-bus output. Here's your CRSF transmit, and here's MavLink transmit, smart audio, or DSMS protocol. Now I chose CRSF transmit for pin 1 on that RC receiver. That's a Crossfire protocol that can do a whole lot faster data transfers than PPM or S-bus, and it allows both communications in both directions, because you can see here output number 2 is going to be automatically set, or you can set it manually to CRSF receive. So we've got a CRSF protocol going on here on output pins 1 and 2, a transmit and a receive. That's a bidirectional protocol. It's much better than PPM, S-bus, any of those, because those don't communicate in both directions. This communicates in both directions, has a very, very, very low latency. So now again, we're going to go back to here on the screen, and we now have ground 5 volts, and we have CRSF transmit coming out of the Crossfire RC receiver going into the flight controller's receive pin on UART 6 here. And we have the CRSF receive pin on the receiver listening to the F765-Wing UART 6 transmit pin right here. So that gives us ground, power, and two-way communications between the RC receiver and the flight controller. We're done. We have a basic setup here. Now there is one further thing we'll look at real quickly here. I'm not going to get deep into this. I did set up output 3 and output 4 on the Crossfire receiver as MavLink receive and transmit. You can't set them up as transmit and receive. Don't know why. It's all part of Crossfire. I'm new to Crossfire. But this is going to transfer the MavLink telemetry data between my platform and my RC radio, and then through Wi-Fi, in truth, it's going to go down to my ground station. But we'll get into that complexity at a later date. Right now, we just want to really concentrate on the fact that we've got a Crossfire protocol going, transmit and receive on pins 1 and 2 from a little RC receiver right here. That's what's coming out these 2 pins. That's wired up to the flight controller, and everybody is happy. Now let's go in and look and see what we do in INav. So now if we come into INav and connect to the flight controller, this is your basic setup. We can go out here real quick to the ports page. I do not know why UART1 is enabled from the get-go in this. I'm new to INav. I've been RDU for almost 10 years, but I have not done any INav. I'm new to Crossfire, I'm new to INav, new to a new radio, all sorts of stuff. But anyway, you can see right here, UART6 already set up. CRSF. This is default firmware version 261, straight out of the box. 261. What version is it? 261, February 25th, 2021. And you can see right here on the ports tab again. Right here on the ports tab. This is all that needs to be set up for that to work. On the ports tab. CRSF, that's it. Now you do have to go into configuration. You do have to go to, where is it? Receiver. That might help. Receiver. Here we go. Right here you set it up as either PPM receiver, serial, MSP, SP, whatever. We're setting up a serial receiver, and down here we're going to choose the CRSF Crossfire protocol from that we set up. Serial port is not inverted, and we'll just leave serial receiver half duplex operation at auto. We're going to save and reboot. I'm going to start up my RC radio.
Yahoo telemetry ready. Welcome to OpenTX. Takeoff. Stabilize mode.
And it has rebooted. Let's see, CRSF. Oh, we're not bound to that receiver. Select the proper model. Sorry about that. There we go. Now we're bound. Okay. Selected the model that actually is connected to that receiver. And now if we look right here on the left, we'll go through my first three channels. Roll. I have roll input. Pitch. I have pitch input. Yaw. I have yaw input. And throttle. I have throttle input. I actually have channel 5, channel 6, channel 7, channel 8, channel 9, channel 10, channel 11, and finally channel 12 set up on this.
That's all there is to connecting a RC receiver to the F765 Wing.
So there you go. There's everything I was working with on the bench. The wiring going over to the little RC receiver. My radio sitting here, and again, you can see when I move the sticks. Let's see, if you go upper right on both of them, all four of those first channels are supposed to go all the way to the right. That should signify they're set up. Bottom left, all four of those channels should go to the fully left. Looks like my, now that goes down to 988. What's going on there? Huh. It's down in that left-hand corner. It doesn't register fully to the left. It goes up to 1102 or 1002. Oh well, it's not much. I always get sidetracked. But there you go. And then some of these switches on here, you saw me flipping. So there it is. There's a F765 controller board with a Crossfire Nano RX receiver connected to it, hooked up with 4 pins, ground voltage, and we're running the CRSF bidirectional protocol on UART 6 of the 765 Wing with very few configurations to INav. Let me see if I can go into my radio real quick and look at what has happened here by connecting up that radio. If I come in here now on that model mix in my radio, go into the model mix, go to the telemetry screen in the radio, you can see down here I have discover new sensors, add new sensors, delete all sensors, but I don't have any sensors. But because the CRSF is a multi-directional protocol, I can say discover new sensors here, click, and I just picked up 18 sensors out of this RC receiver and the flight controller that are coming over from the RC receiver because of the CRSF serial protocol. I have RSS values, quality, link quality, serial and noise. I have battery, transmitter quality. Here's pitch. If I pick up the flight controller and pitch it around, you can see that value changes based on me moving the flight controller around. Roll, yaw, receiver battery voltage. Some of this needs to be set up. But see, now I'm getting telemetry. Basic 18 sensors of telemetry data between the flight controller RC receiver back into my radio, and I haven't even turned on MavLink yet to get further information from the flight controller. But MavLink is used in Ardu, not in INav. So, but there you go. There's 18 sensors. Oops, stop discovery here. There's 18 sensors. There's vertical speed, battery current. that is telemetry that I'm getting between my flight controller, my RC receiver, and my handheld ground RC transmitter. You're beginning to see why I just changed to a new RC receiver system that's as small as a postage stamp. Costs about the same. $24 to mail a letter pretty soon. Sorry, didn't mean to get into politics. Got a brand new radio. Communicating in new ways between my receiver, my radio, and my platform. I'm doing new things on a 765-Wing. I'm doing new things on a Crossfire transmitter, receiver. So, guess that's the end of this video. That's how simple it is to hook a RC receiver into a Matek F765-Wing flight controller.